Audioterm Synthesized Loop, SLOOP, Loop Synthesis. Alright, let's cover some theory. This is Matthias. K-term will be bundled with a synthesized loop generator for drones. SLOOP, this is a tool that is based on the synthesized loop function of the Ensoniq EPS-ASR, only much more flexible. If necessary, you can make an endless loop from a bass drum or ZBSP surface sounds from pelvic sounds. Great. Works in contrast to the original, also with stereo files without phase problems. This is the manual for the EPS 16 Plus. This is Synthesized Loop. This is the algorithm to use when all other looping techniques have failed to make a smooth loop. Unlike other looping algorithms, the synth loop uses a certain amount of random data processing. It is a loop anything algorithm, which works well with special effects. With the smoothness parameter, the smoother the loop, the more processes the EPS 16 Plus goes through to create the synth loop. For example, if you do synth loop on a voice sample and the smoothness is set to very coarse, it may create a loop that sounds irregular or nervous. And I'm going to add jittery or staccato, and we'll see that in a moment. At the other extreme, if the setting is too fine, it may sound metallic, and we'll hear that too, and that's probably a flanging effect just from too many waves. Well, I didn't want to go into this, but let's get out of here. Okay. Audioterm Synthesized Loop. We've got system, which is our current one, disk, and synthesizer, loop synthesizer. If I go into synthesizer or loop synthesis, I can't do anything. I can't create something from nothing. So I need to go to disk, and I've got a loop here. It's not really a loop. It's a banjo passage here. And I've chosen it for a couple of reasons. It has it's kind of has a pluck nature to it. It has some airy spots, some quiet spots, and it also has different pitches on the duration, and also at the very end there's just that long hanging note at the end. So I'm going to highlight the strengths of those qualities. But you can use anything, and like they said, you can make a drone out of a bass drum if you want to. Alright, so let's load it. And here's the file up here. What we've got here is an envelope that we can control. E-reset is envelope reset. Puts it back up. And what this does is it's a one-for-one relationship. If it tells the system which parts of the source input file I want to loop synthesize. So right now we're choosing all, but a technique I discovered on my own, and I'll illustrate it, is picking out little pieces. And I'll show you why I like to do that. Okay, this setting is on maximum. This is spectral density and spectral smearing. Smearing, I know, has to do with how many copies there are being played and at different time intervals. Spectral density I don't know, it's much more of a how many iterations of this input file am I going to add on a very close basis. Whereas spectral smearing seems to me like I'll show you in a minute, it might play one here and one here if I set it on 2. But spectral density would play one here and one here if I had 2. Anyway, I'll try to illustrate that with audio. Okay, I can play the input file, and I can play the output file. Of course, there's nothing. Every time you make a change in loop synthesis, we have to compute to get an output file. I don't want to play this yet because this is not the way first thing I want you to hear. I'm going to take everything down to 1. So compute that, and 1 density, 1 smearing. I should have the same thing. Okay, I do. If we increase, I'm going to increase the density a little bit, and it's not going to be that audible. And look up here how they're linked. Okay. I want to take spectral smearing back down to 1. Okay, and let's compute that. Let's hear what we've got. Okay, it doesn't sound much different. But when I make this change right here to 2, we're going to hear those 2 iterations I was telling you about, where you hear one here and one part way down. There's 2. Okay, it's kind of like a digital delay effect. I think I can make that more pronounced. Okay, it's much longer time span between the 2 beginnings. Alright, now let's start to really ratchet things up. Okay, it's starting to be just one solid sound. I've reduced my smearing down again. That's the jittery effect that they were alluding to. And if we get too high with the smearing, we get the flanging effect. Let's crank it all the way up. Okay, I'm going to reduce it down to that much. And what I like to do is reduce everything down to where I don't have what I consider to be artifacts. I'm just experimenting here. I didn't practice this. Okay, so I can also have a bi-directional aspect where it will play one copy one way and one copy the other. So let's take it back down to something simple here. And let's turn bi-directional on. Should be fairly obvious. Right? Hopefully you could hear one playing frontwards and one playing backwards. And in fact you can see the beginning here, over here mirrored, and see a little passage right there played backwards right there. And actually right there seems to be the joining point. Okay, let's get rid of bi-directional, and I want to demo stereo widening, which I think sounds pretty good. If you've got headphones on. Turning it off. Definitely has a big effect. I'm turning it off, and I'm going to do reverse. Take it back down to something simple here. Just playing it backwards. Kind of an overly complicated way to reverse a file if that's all you want to do, but you can. Let's I want to give you an example where there's still a little bit of rhythmicness to it that you can hear. And I want to highlight this out to in, so I can take the output file and put it up here if I want to process it some more. So I'm going to put this one up here. Here we go. Hey, there it is. And I could process it even more. I can use the same settings or different ones. I'm going to use the same for now. You can hear the sound got denser. So if for some reason on the first try you can't get the density you're looking for, then you can just reprocess it again. Alright, I'm gonna turn this up pretty high. That's fairly solid, and now I want to demonstrate this. Actually, I want to reload the file. And now I'm going to show you that technique that I noticed. And I've turned it all off. It's not looking at any of the input file. Let's say we want to just look at the first pluck of the banjo. If it's not dense enough, I can increase it. Not a huge difference. Okay, I'm going to try a different area. One thing you've got to notice is that this is normalized. So if I use this amount or this amount, it's going to always normalize it if you're only looking at one specific small area. If I'm using two areas, then the amount that I choose will make a difference. Let me demonstrate that. Small amount. Large amount. No change. Small amount. Let's add a little bit of whatever's up here. Add a little more. And now, because this is going to be more relative to this, I will hear it more. Alright, again, this is kind of a, well, it's a normalization of the signal, whatever you feed it. Alright, so I just wanted to, otherwise I wanted to show you how I can just look at small portions of the input file. I'm looking at the tail end of it here. Okay, it's just synthesizing the loop from that very end of the file. It's very neat. So I can do anything. Disk operations. you'll notice there is no F type here. We only pull in from and save to the samples directory. And in the save process, we come up with a new screen. Loop start, where it starts reading the source, the actual, not the source file, but the file we've rendered, where it starts reading it when you press play, or when you start playing the file that we output. You can select up here or down here. I'm not sure exactly where a good starting point would be. I've been choosing dips, but I don't really know if it helps or not. Really don't know. Some source material, it may have a more pronounced effect. So that's loop start, and that's showing up here in this window. Bits per sample, I'm sorry, loop start reset, I forgot to mention, this just brings you back to 0. Bits per sample, we've seen this before. Level alignment, alright. Level aligned, here's the button. Level alignment to source, or level alignment full range. In other words, do you want the peaks to be as high as the source material, or do you want to use the full range of the file format? And then we can store it. And that's it. It exists on the hard drive. And that's the end of Synthesizer Loop.